Hi guys, yeah, welcome back once again to this operating system programming concepts. And today our topic is make files, and we are going to start lab number 2, the theoretical concepts for lab number 2, right? Okay, now before beginning the topic, so I just would like to present you some kind of funky situation here. That is, this situation is presented because the motivation of this think class is just to make all the students understand that you have to always start studying with a smile in your face. So let's begin. And this funky situation is a height of Facebook addiction. Okay, so a boy's Facebook status goes like this, like I'm online on Facebook during lecture class, ha ha ha. Okay, so he's online during the lecture, and comment from his professor, get out of this class now. Okay, and dean like the comment. So friends commented, come fast dude, there is a funky situation in the cafe, right? So now the gatekeeper comment, okay sir, first come to the gate and lock up your bike. Okay, and then lastly the mom commented that stupid, useless, if there's no need to take class, then just take some vegetables for dinner and come straight back to home. Okay, this was some kind of funky situation here created because of the Facebook addiction. Now let's begin our session, and the topic is Makefiles. So what is this Makefiles? Makefiles are a special format of files, okay, that is used to make, okay, that uses, okay, also you can say that uses the Makefile utility and helps to automatically build and manage our projects. Okay, something like automatically building and managing our projects. And in which condition, okay, like Makefile is very useful in the conditions like when we have several source files, and it is very tedious to type the compiling command every time, right? So whenever you want to solve such kind of situation, we use Makefiles. There is a special Makefile in which all the compiling commands are stored there. Okay, so it is compiled all at once. Okay, all the commands that are written in this Makefile are compiled all at once. Okay, so this just makes our work easier, right? We do not have to compile each and every time, like whenever the source file occurs, right? So this is the situation. Okay, now let's check out the manual of the Makefile. Okay, you go to the terminal. Yeah, you can see the manual of the Makefile. It says that GNU make utility to maintain groups of programs. Okay, a lot of groups of programs. So there is some kind of synopsis, means the format on which the Makefile is operated, like Makefile command is used, and then also there are some kind of warnings, the description, all the documentation is provided here, right, with the particular options and everything. Okay. Okay, so now let's check out how Makefiles are organized. Then the Makefiles are organized in certain format, and this format is provided here. Okay, the format says that there is a target, and you have to start your command by typing a tab. Okay, so after just typing a tab, you start your command. This all the system commands. First is the target. Okay, we'll go through the examples just before, and also here is some kind of dependencies are kept right after the target. Okay, so how do we use dependency there? This kind of dependency, how do we use it? And when do we use, like sometimes when you have multiple targets, right? So if you go and check out this example, you have multiple targets. This is target 1, that is compile, install is target 2, and cleaning is target 3. Okay, so all these commands, system commands, are written after the tab, right? And you are just compiling this main.c file and generating executable file. So compile is presented here like as a dependency, and this is why is this dependency used is that just to notify that the compile target will be executed before install. That means this is the first priority. On the priority wise, compile will be executed first or before this install target. Okay, so this target has a priority or preference than this target. So this is just to say that like this. So only after compiling, this kind of install target is executed. Okay, so this is the situation of using the Makefile. Also, for convenience, we use some kind of variables to declare all these system commands while using the Makefile, and these variables are used because whenever, if you want, for example, if you want like multiple compilers, okay, different type of compilers, okay, then the same Makefile can be useful, because you do not have to type like 2 or 3, 4 or 5 kind of Makefiles. Just use one Makefile. Just try to define all the variables, okay, declare the variables, then initialize it with the compiler. So whenever if you want to change the compiler, you can just change the variable, okay, like initialization, it's just initialize with a different variable. So similarly you can just use this Makefile by declaring and initializing the variable. And this is one of the important feature of also a Makefile. Then how do you use the make command? Then we can use the make command by typing such kind of make. There is a make command here, okay, so you can type a make command to use these make files. We first create the make files, then we, in our Linux terminal, we use the make command to make use of this make file. And you can also check the manual of we already checked the manual of this make, right? Utility to maintain groups of programs. So what it does is just this make command will look for the file named Makefile in our directory and execute it. Okay, whenever you type the Makefile like make command in the current directory, in the working directory, the Makefile, this make command will look after the Makefile, then try to execute it. Okay, so if you have several kinds of Makefile, then you can also use this particular command to execute the Makefiles. Because okay, look, you can check out here. Okay, so similarly, look at the situation is all shown here. File, Makefile, dash f file, dash f file Makefile. Okay, you can check out all this manual here. Okay, and the options, everything is documented there. So how does the build process works in GCC? Okay, the compiler, GCC compiler is like, compiler takes the source file and output object file first. So you use this command GCC on the option -c just to create the object file. And this, in the linker, we take the object file and create the executable file. So these are the two important process, build process, that you have to understand. Now there are some kind of special functions for copying files and there are special functions. There are many special kind of functions, not only, yeah, but let's go and check out. Like in fgetc, what this function does is like it takes the parameter input string, like gets the next character, an unsigned character from the specified string, that is this string, and advances the position indicator for the string. So it just gets the next character, so it keeps on reading. It's like reading from the specified string, file string, and advancing the position indicator for the string. So this means it is reading continuously. Whereas this file, this function character pointer fgetS, with its defined parameters are character restrict as integer of and file restrict string. Okay, what it does, it reads the bytes from the string into the array pointed to by s. So it reads the byte from this string, this file stream, then it reads to this location pointed by this as, and until n-1 bytes are reached. So maximum size that it can read is to this integer number n, the n-1, or a new line is read and transferred to as, or an end of the file condition is encountered. The string is then terminated with a null byte. Okay, so these are some familiar functions, right? Whereas we can also use fscanf. Similarly, it reads the bytes, interprets them according to the format, and stores the result in its argument. It stores in this argument. Okay, reads from the file stream and it stores in the arguments. Okay, corresponding argument. Whereas printf for format text string on output format, so just prints okay. So there are some kind of some more functions, right? Fret. Okay, if you can, also go and check out fret. They are the binary streams. Okay, input and output. They just do the binary stream input and output. They just, the documentation is all provided here. The function frets read and mem elements of data each size bytes long for the stream pointed to by stream, storing them at a location given by pointer. So okay, even we have fwrite and fread. Okay, fread and fwrite, everything is provided in the documentation. So these are some kind of useful functions or special functions that can be useful for copying files or something, and mostly while manipulating or working with the files. So fread, it reads the n-member element of the data, each of the size bytes long, okay, this is the size bytes long, from the stream pointed to by stream. This is okay, it reads from this stream and storing them at the location given by pointer. So it stores here, reads this number of elements of size, this reads from here and stores it here. Okay, this is the situation. Whereas also for size, and it returns the size underscore t. Whereas this one fwrite also does the same thing. Okay, writes n-member element of data, each size bytes long, to stream pointed to by stream, obtaining them from the location given by pointer. So it just writes reading from this string of size n-member, okay, and the maximum n elements of this maximum size, and lastly it writes it to this location that is pointed by this pointer. They return the number of items successfully read or written, not the number of characters. So they do not return the number of characters. Okay, they return the number of items successfully read or write. So this is the number of items. Okay, you can check out the type here, number of items. If an error occurs or the end of file is reached, then the return value is a sort item count, that is 0. If error occurs, the return value is 0. So fread do not distinguish between end of file and error. So fread, it do not distinguish between end of file and error. So it does not check whether it is end of file or an error. Okay, the caller must use the f end of file and f error to determine which occurred. Okay, this is the idea. Also, there are some kind of functions like POSIX functions like read and write. So let's go and check out the manual of read. Yeah, read from the file descriptor. The description is provided. Read attempts to read of the count bytes from the file descriptor fd. So this is the file descriptor fd into the buffer starting at buffer of size is count. Okay, and other information is provided here. Now let's see. Yeah, this is the file descriptor. Attempt to read n bytes from the file associated with the open file descriptor into the buffer 22 by buffer buf. Okay, on success the number of bytes read is returned. So number of bytes read is returned. So 0 means the end of the file and file position is advanced by this number. So even for write, attempts to write n bytes from the buffer 22 by buff to the file associated with the open file descriptor. Okay, on success the number of bytes returned is returned. 0 indicates nothing was returned, and error is pointed by error returned is -1. Okay, lastly, what is the redirection then? Redirection is something like the process in which we can redirect the standard streams, means standard input and output streams, to the user specified location. Okay, so this is the most important idea about redirection. So you can redirect all the input and output streams to the specified location where the user wants. And so there are some kind of symbols that are used to perform this, or some kind of commands that are used to perform the specific kinds of redirection. There are just using the greater signs means redirecting the standard output. Okay, from standard output we redirect to the file. So it's like something standard output to a particular file you can redirect. So on the right side there will be a standard output, whereas the output of that location, okay, whereas you redirect this standard output to the another new file, okay, on the right side. Whereas also here you have to understand there are left and right side. So it is always redirected from the left and going to the right, okay, location. Here also you are redirecting from left, okay, the standard output and standard error both included to the right location, okay, of file or some locations. Whereas here you redirect the standard input to the location or file. That means it is directing from not from left to right, but from right to left. So it's redirecting the standard input to the file location. Whereas here this one, greater than or not sign, we redirect from left to right, and we redirect the standard output and override the file if it exists. So we redirect the standard output from left and we go to the right location and override the file if it exists. Whereas also here you will redirect standard output and standard error and override the file if it exists, okay. And this is the pipe symbol in which we redirect the standard output to the another command, okay. So this means from left we redirect to the standard, like we redirect this standard input of right to another command that is in the location right. Okay, so from left the standard output is redirect or piped to the another command that is located in right direction. So also this double greater sign is appends the standard output. So all the standard output is appended to this new location that is on right. Whereas also here we append the standard output plus the standard error to the right location. Now lastly, okay, just a bit tip about the format for changing the permission. This is the particular format for changing the permission, and the format is always same. And first we write the keyword change mode, and who, like who means anybody, like user or group. Like before we described there are different permission for different classes of users, like either user or like the normal user or group or others, okay, or all. So this kind of users can be specified, like you can specify U or G or O or A. Whereas also there are operators, okay, operators come, and operators are either plus or minus or equals. Plus means either you add the permission or you remove the permission or set the permission. And there are three kind of types of permission. They are read or write or execute. Okay, so this kind of three kind of permissions for this particular file name. You can also check the manual, and here everything is provided in detail. Option, mode, okay, and the file. Okay, so this is it for our second lab. Okay, we will be doing the programming. In the next video we will be doing something about like the programming. Okay, the programming concept. We'll go to the programming concept of this Makefiles. That means we will just do some kind of, we'll try to solve some programming problems related with the Makefiles. Okay, thank you for listening.